Alright, so here it says use the circuit at the right to answer the following. Alright, is this a series or a parallel circuit? Alright, it is a parallel circuit, although we do have a few resistors that are in series. It is a parallel circuit. Alright, so first let's go ahead and map out our voltages. We know we have 0 volts at the tail end because this is the negative side of the first battery. Let's go ahead and label our battery sides here. Alright, and our voltage is going to continue to be 0 until we run into anything. So it's 0 all along the bottom here. Alright, and then here on the left side we go through a 9-volt battery. So here we're going to have 9 volts, and then we go through another 9-volt battery. So we're going to have 18 volts. And then we're going to continue to have 18 volts until we run into something that is either going to add or subtract our voltage. Alright, so here is a split in the wire. And here's another split in the wire, but we still have 18 volts going to it because our voltage does not change unless we go through something. Alright, so okie dokie. It wants to know what the voltage difference is from B to E. Alright, so at B we had 9 volts, and at E we have 18 volts, so we changed by 9 volts. Alright, it wants to know what is the total resistance between points D and K, which is the first branch, D and K. Alright, so these two resistors are in series, and when you're in series, you just add up your resistance. So we have 4 ohms and 2 ohms, and that's going to give us a total of 6 ohms. Alright, so what is the total resistance between D and K? 6 ohms. Alright, now it wants to know the current through point G. Alright, so current through point G, well, we know that current, and we'll go ahead and pick a different color. Current is voltage over resistance. Alright, the voltage going in is 18. And our resistance is 6 ohms. So 18 divided by 6, we get 3 amps going along this circuit. So this here is 3 amps. Alright, if the 4 ohm resistor was replaced by a wire, how would the total current change? Well, if you decrease your resistance here, it's going to increase your current. So it would increase. Alright, if branch 3 was broken at point H, so right here, how would the current flowing through the 4 ohm resistor change? Well, no matter whether this gets cut off or not, we're still going to have 18 volts going through this resistor. And the resistance doesn't change, the voltage doesn't change, these two things don't change, so our current wouldn't change. It wouldn't change. Alright, so now it wants to know the current from J to K, which is J to K. It wants to know the current. Alright, so we need to start calculating. We'll go back to this blue color that I used for current. Current is V over R, so here we have 18, which is V, over our resistance, R, which is 3 ohms here. 18 divided by 3 is 6 amps, and it's going that direction. Alright, here we have 2 resistors that are in series, so we just add up the resistance, and 7 plus 5 is 12 ohms. And our total voltage was 18, our total resistance is 12, and we divide 18 by 12, and get 1.5. So we have 1.5 amps over here. Alright, so we have 1.5 amps going, and then it runs into this 6 amp current, so 6 plus 1.5 amps is going to give us 7.5 amps. So from J to K, we're going to have 7.5 amps. But that is not our total current, because we still have another join to make with the 3 amps, so 3 and 7.5 are equal to 10.5 amps. We don't have any more splits or joins in the circuit, so this ends up being our total current, and 18 volts ends up being our total voltage. Alright, so our total current is 10.5 amps. Okay, and then we can actually calculate our total resistance. Since current I equals V over R, we can actually manipulate this equation to make R equal to V over I. We actually just swap these two. Alright, and our total voltage is 18. Our total current is 10.5, and if we divide these two, we can find our total resistance. So here we have 18 divided by 10.5, and we get 1.7 ohms. 1.7 ohms. Alright? And we should be able to do our R total is 1 over R1 plus 1 over R2 plus 1 over R3. And we can go ahead and try that to just confirm that we're doing the right thing here. Our total resistance on this line is 6 ohms, so 1 over 6 plus the next one, 1 over 3 plus the next one, 1 over, and our total resistance is 12. Close those parentheses, and we get the same exact number, 1.7. Alright, so 2 ways of accomplishing finding the total resistance here. Okay, Jay asks us, what is the voltage at point G? So at point G, we actually, since these are in series, we need to calculate the voltage drop for the first resistor. So we know that the voltage they spend, and I'll go ahead and take this up over here, the voltage that it spends is going to be V equals I times R. Now the current we decided was 3 amps, and the resistance here for that particular one is 12 volts. So we had 18 going in, we spent 12, so we are actually, I'm going to switch back to green, we are going to have 18 minus 12, which is 6 volts at point G. So at point G we have 6 volts. And we should be able to go back and double check. If we measure the voltage across this resistor, it should be 6 volts, because 6 minus 6 is going to give us 0. So using the same thing, V equals IR, I is 3, R is 2, and that equals 6 volts, which is exactly what we needed to have a voltage drop to give us 0 volts afterwards. Alright, and then now it wants us to tell them what the power of the total parallel circuit is. So power is voltage times current. Our total voltage is 18, and our total current is 10.5. So when we multiply these two together, 18 times 10.5, whoa, I've got quite a bit, 10.5, it's 189, and since it's power, it's 189 watts. And we're done.